Homework 1.6, other types of equations, video 6. Homework's due on Saturday, May 16th, 2020 at 11:59 p.m. In the previous video, we were introduced to quadratic-like equations, what constituted them, and a procedure for solving them. I did erase the when to do this, but just to remind you, it's when you have two matching bases where one power is twice the other. But if you take a look at this one, it's a little more intimidating. Solve the quantity x squared minus 2x squared minus 11 times the quantity x squared minus 2x plus 24 equals 0. For those who don't know about substitution or quadratic-like equations, their first instinct might be to FOIL this first squared binomial, distribute across the middle, combine like terms, and go from there. But I'll tell you right now, doing that will put us in a position that we don't know how to get out of. Later we will, but for now we wouldn't be able to get out of it. But do you notice something about the two parentheses? Aren't they kind of the same? This one has a power on it, this one doesn't, but it does. If something doesn't have a power on it, you can't see it because it's a 1. So this equation, as messed up as it looks like, fits the criteria for being a quadratic-like equation. These two bases match. Remember, a base is something with the power on it. One power is twice the other. So this is screaming substitution, substitution. So how do you do a substitution? You let u equal the lesser of the two powers. So we're going to let u equal this. X squared minus 2x to the first, and as a consequence, u squared is equal to x squared minus 2x to the second. So the parts that are circled in red are about to get a substitution, get a nickname if you will. This part becomes u squared minus 11. This part becomes u plus 24 is equal to 0. And by the way, you don't have to use different colors when you're doing these. I'm just using them to illustrate where we made the substitution and keeping track of where it is in red. And if you're colorblind, some of this is red and some of it is black. Oh, look, it's a quadratic equation, and it's one that will factor pretty easily. You may get out the quadratic formula, but I need two numbers that add to give negative 11 and multiply to give positive 24. Because they add to give a negative, the larger number must be negative. Because they multiply to give a positive, they must have the same sign, so both are negative. And the numbers are 3 and 8. So if I set each factor equal to 0, I get u equals 3, and I get u equals 8. But we're not out of the woods yet. The substitution is temporary. It helps us solve the quadratic equation. But at the end, we have to change the u back to what it was holding the place for. In this case, u is holding the place of x squared minus 2x to the first power. But let's be honest, the first power part here really isn't necessary. And as a consequence, neither are the parentheses. So I can just change each u back to x squared minus 2x. So we have x squared minus 2x is equal to 3, and we have x squared minus 2x is equal to 8. And now we just finished solving. Yay, we have two more quadratic equations. Again, you're welcome to use the quadratic formula. I prefer factoring, but we shouldn't do either until these are equal to 0. So the 3 moves over, gives us x squared minus 2x minus 3 is equal to 0. And the 8 moves over, giving us x squared minus 2x minus 8 is equal to 0. You can see why having more moves in your arsenal besides the quadratic formula is important. When this is over, we'll have solved 3 quadratic equations. The original one after the substitution, and then the 2 more after we unsubstituted. So however much longer it takes you to do the quadratic formula than factoring, multiply it times 3 for this problem. But I'll get off my soapbox. X squared minus 2x minus 3 will factor into x minus 3 and x plus 1. You can check it. So the two solutions here are 3 and negative 1. But over here, x squared minus 2x minus 8 is factors into x minus 4 and x plus 2. Yeah. And so our other two solutions are positive 4 and negative 2. So substitution is not meant to be a quick process. It really depends upon the structure of the substitution and the caliber of the equations that you get afterwards. But like I said, they're pretty straightforward. This one was based off of number 11 in homework 1.6. So at this point, you really want to go to homework 1.6 and try to knock out these 4 problems. 2 more videos, because there's one more technique, or one more type of equation. Wow, we really went through that one pretty quick. Sorry, I hope it wasn't too fast. By the way, any feedback you can give me on these videos are appreciated. More detail, less detail, faster, slower, more videos, less videos. I'm here to help you.